This is the first experiment lab in Physics 2212. In this lab, our main objective is to find the amount of excess charge in common household items such as tape. Make simplifying assumptions to make the calculation process easier. We apply both Newton's second law and the electric field equations to find out how these charges would interact and to eventually find the answer we're looking for. Now we're going to talk about the physics concept needed for this lab. Coulomb's law is very useful to find force between two point charges located at a distance r away. The second concept is very fundamental. It's the equation of gravity acting on an object on Earth. Newton's second law states that the net force acting on an object is the rate of change of its momentum. An object is in equilibrium has zero change in its momentum, therefore no force acting on it. Therefore the net force on the object would be zero. We start the experiment by creating a charged U-tape by pulling apart from the base U-tape, and then we bring it close to a negatively charged pin or cone to test what charge the U-tape has. We observe whether they repel or attract. In our case, they attract. Therefore, we conclude that the tape is positively charged. Then we move on to create two charged U-tapes, put them on top of each other in a way the top one floats, and then we find distance between the two tapes. More details can be seen in the picture. The amount of charge should fluctuate due to us touching it, but for simplicity's sake, we say that each U-tape has the same exact charge. We treat each U-tape as point charges because otherwise we'd have to consider things like charge distribution on the tapes and etc. We ignore air resistance to further simplify the problem. The two U-tapes repel each other, therefore indicating they have the same polarity of charges. The U-tape was retracted to negatively charged cone, therefore indicating both U-tapes have positive charge. We collect three data points: length of tape, mass of tape, and distance between the floating tapes when B is floating. Moving on to calculations, we start out by finding the gravitational force on tape B. Then by drawing a free body diagram on tape B, we found out that the electric force and the gravitational forces are opposite. Also, since the tape is floating, the net force on the tape according to Newton's second law is zero because the change of momentum is zero. We set the magnitudes equal to each other and continue. Note, by the way, in our assumptions, we said that we assumed both charges to be equal in tape A and B. Therefore, we can just say that Q1 times Q2, the magnitude of Q1 times Q2, is just equal to Q squared. And then we calculate Q by switching over variables here and there. Since we know the tapes are positively charged, they must be electron deficient. We know the charge of electron is 1.6 times 10 to the power negative 19 coulombs. Dividing charge by electrons charge, we get the number of electrons. To find the number of atoms, we just divide the tape's surface area by the atom's area. And we find out the ratio by dividing the two numbers that we just got. And we find the ratio of deficient electrons to atoms to be 1.458 times 10 to the power negative 7 electrons per atoms. This is a computer simulation of the experiment using GlowScript. We can see the results here. The top particle is tape B while the bottom particle is tape A. We can see the forces acting on them in the simulation. Forces acting on B are equal in the opposite direction. Therefore, it results in a stationary state or floating state. While the green arrow is the electric force on tape A from tape B. Here's the code in smaller chunks to make it easier to understand. We have the constants declared at the start, then we go ahead to make point particles, then arrows, then print statements. If the electrons are positive and protons were negative, none of the observations will change, since charges with the same polarity or sign always repel anyway. The next question is, why is it important to touch the tapes as little as possible? Our bodies are conductors. They are pretty good at conducting electricity because of our sweat glands and our skin and whatnot. Touching the object over time would result in the excess electrons from a hand to the tape until both objects are neutralized. Therefore, the tape would lose its positively charged state. This would totally question the validity of our theoretical calculations since it totally based on the tape being positively charged. That's it. See you in lab 2.